Okay, now Stefan with AI assistance for manufacturing data analysis. Have fun.
Yeah, thanks for the introduction. Thank you for sticking around this late afternoon. I'm happy to be here to talk a little bit more about a topic that we've spent quite some time on over the last year, and which I think gives another perspective on what we just heard about agentic systems and about AI assistant. I don't have a Mentimeter, but I'd really hope to interact with you. So I would be very happy to hear your thoughts, questions, and maybe criticism to what I'm talking about here today. And I would like to start with an insight or a thesis that in 10 years, knowledge workers in manufacturing will use AI assistants across all tasks. Who of you would say yes to that thesis or would sign this thesis? Maybe you can, everybody who agrees, maybe just raise your hand. Maybe the counter example, who won't agree to this thesis? Good. Please be. I think most people, when I ask this question, will agree, and maybe it's also like the bubble we are in here, right? Very like forward thinking about the future. But I definitely would agree as well, and I think even this like very basic thesis is very profound, as we will see later on. And I think the next thesis is also, I think, maybe not so direct, but also very important. So today, when I log into my video editing tool or my IDE for programming, my customer relationship management system, my whiteboard, whatever, I always have this co-pilot in every piece of software, right? But I think it was quite clear from the previous talks that what I want instead is actually having one assistant that has like the capabilities of like all these different systems in one place. And even today, for me, that's very important because oftentimes instead of using these specialized assistants, co-pilots in the specific software, I actually rather use ChatGPT instead. And I think there are some counter arguments to be made that, for example, in your programming IDE, you will have well-integrated systems for this specific purpose. But I think generally it will be in a way that you have this one assistant. And that has super, super profound impact on how the data structures are built, how the UIs are built. And I just want to really point this out because I think when you heard it for the first time, you won't like process like what this actually means. And I would like, again, to pick this example of Klarna. We heard it today. It's a payment provider from Sweden, and they're very public about how they use AI. And if you are in a similar LinkedIn bubble as myself, you'll probably hear this, but they have this internal assistant. And what they actually did is they ditched Salesforce as their CRM. So they ditched like a really big part of the internal software stack and replaced it with functionality in their assistant, right? And they have like two motivations for doing this. One is they said, oh, there are many features in Salesforce we don't use anyway, and it's expensive. So instead, we just program our own. We do it with AI. We do it fast. But this was not the main motivation. The main motivation is that they said, okay, I have this data in Salesforce and it's not accessible to my assistant, and that's bad, right? And I think if you really think this through and you want this one assistant like Klarna has with their Kiki, I think it's called internal assistant, you have to have all the data infrastructure in place actually across your whole organization to actually be able to build this. So this is a very, very profound insight. And the last insight that we learned across many, many projects, not just generative AI projects, but generally machine learning project, is that the user interfaces are always key for the performance. They win the game, but they're still underappreciated by a lot. And I give you just one example, and we heard this today as well, is when you're using this assistants that actually give you information about the sources for the answers. In all the reference implementations, right? If you go online and you get the first result from GitHub, here, build my chatbot in 5 minutes. You'll never have the ability to actually click into your documents and actually highlight the chunk where the information is retrieved. And this is something that many people, including, for example, Festo's team and our team, started building like as a first thing, as the first thing to improve the overall performance of the system. This won't show up in any like quantitative metrics. It's not going to be 90% accurate instead of 80% accurate, but in terms of user adoption, and I think you can imagine, even if you haven't used such a system never before, that this is super important. Right, so yeah, coming from these insights, and we will now see a little bit how this will connect to how we approach this topic of AI assistance for data analysis. I will make a confession, and that is that I'm not a manufacturing data expert. Actually, my hands-on experience comes from the automotive industry, where we build systems to analyze testing data, both from test fleets, right, from test benches, but also actually from actual fleet data. And today I actually learned something in the opening remarks from Ansgar Krivet when he told us that I think 1/3 of the development time is spent on testing, and also Festo is generating a lot of testing data. And I think there's also probably a bit of a similarity in the manufacturing industry, that you have this testing data available, you have to understand it, and sometimes you can even use the testing data actually to understand the fleet data a little bit more. So that's the direction where we are coming from. And I would emphasize a little bit the key challenges in this area. And again, I think some of them might be a bit more specific to automotive, but some of them probably generalize very straightforwardly into the manufacturing domain. And the first, or the overall problem is that the data is siloed along many dimensions. And the first dimension basically is the data formats. So our team actually spent days, I think maybe even weeks, to just reverse engineer some format, bring it into like a standardized package to actually be able to really work well with this data. This is a problem in the automotive industry that's nearly solved, I would say, for most teams, not for all teams, but that was a big pain. And now this data lives basically in two worlds. So in one world, we have the data in a data lakehouse, and we have data experts building dashboards with Power BI, for example, to understand fleet behavior, to build dashboards on testing results. And on the other hand, we have engineers using test data analysis tools that actually don't focus on fleets of vehicles, but that focus on very specific test runs, on very specific moments to inspect raw data. And these two worlds are apart. So if, as an engineer, I have a new question about the performance of my vehicles, actually I have to go to my data expert colleague. They have to build a dashboard for me. Then I get this dashboard. Then I can maybe look at this a week later. Then I see in the dashboard that at certain moments interesting stuff happens. Then I have to download the data from a different from a different disk or a different location, analyze it with a different tool. So if we summarize this, right, then the problem is that we have a lot of data. We have a lot of data, but the accessibility by the engineers is really poor, right? And that is for all different stakeholders, for example, for the test engineer, obviously, but also for the product development engineer who wants to understand how the project is actually used, for example. This is very poor. And from all my discussions with teams in manufacturing, I understand that this is a big problem here too. And the next problem is the semantic data description. So even if you have your data in your data lakehouse, right, a fully instrumented test vehicles has thousands of channels. And obviously, sometimes they have funny names, right? Sometimes as an engineer, I only know about the channels that are related to my subcomponent. Right? So understanding the context is super important. And the last point, and this is still true today, it's still a challenge in a specific context to find data infrastructure that can support these queries and that is efficient and cheap enough. So what do we want to build? We want to build an assistant for manufacturing expert to extract relevant information from documents and data. And I think, especially in the light of the previous talks, this is a rather modest vision. I think you could extend it saying, I not just want to extract information, I want actually to take action on certain things, right? But I think even this like modest vision is super powerful, and it really will fundamentally change how we have to think about all the software products we build, the tooling, the customer touch points, and so on and so forth. Right. And now I would like to give you a little bit of an example from automotive. It's a super simple demo. It's also not optimized for being seen from far beyond. I hope you can read this. So here we have different channels from our CAN bus data. I think it's about 50. Again, in reality, it can be thousands, and we have stuff like velocity, temperature, and so on and so forth. And the first thing I do is I ask a simple question. What channels are relevant for battery health, right? And here I use a super simple model, but still the model knows that stuff like temperature, current, operating time, voltage, and so on and so forth is important. So even with the simplest version, I can give a lot of context to the data. And I obviously can improve this context, for example, by adding glossaries, by adding documentation, right? I can also ask, show me the maximum battery temperature, or I can ask, please show me all the incidents where the battery temperature was greater as a certain threshold. So in fact, what I can do is I can hit the database with queries that were previously where we previously needed a data expert that knows SQL, a database language. I can drag and drop visualizations, and in this way I can actually navigate my data super quickly, even as an engineer. I can also attach different other subroutines, agents, or transformations. For example, here I can attach an anomaly detection and can work with that as well. And I think the demo shows that such assistants are a huge enabler to democratize the access to data, and that they work very well, and this was one of the previous theses, if you have the right UI toolkit around it, because you have to have this interplay between answers from the assistant and proving the answers in terms of actually looking into the data or looking into the document yourself, understanding what's going on, zooming into the different results and events. Right, so I don't want to go too much into detail how this actually works. I think I can actually skip this slide. I think you had some great slides about how retrieval augmented generation, how this process generally works, that I have this agent that has database access to documents or the data lakehouse, and then that helps me to complete the query. So again, if you're interested in the more technical details, feel free to talk to me later on. I'm really happy to talk about like everything that goes on the models used and all these things. Here, I would just mention several things. First, we have obviously several layers, right? Just at the top, we have this UI layer. At the bottom, we have the data infrastructure layer. And in the middle, we have LLMs and agents, or LLMs that can call different simple agents to perform tasks for retrieval and visualization. One important agent is a SQL agent that can transform natural language queries into a database query. One important agent is typically that in automotive testing data analysis, the teams already have Python libraries that perform some feature extraction, right, or some other transformation that are important for the domain. You have a visualization agent, but you can have different things. And on the bottom what I think is super interesting is that on the one hand, these data lakehouses are a huge enabler for this technology because they provide a SQL endpoint, and you can actually store like huge amounts of data in a quite reasonably efficient way. And on the other side, what we actually found is what's super interesting is that for smaller teams that have small amounts of data, there is an emergent new stack that also allows you to build a SQL endpoint. And this is based on Parquet as a file format and in-process databases like DuckDB. And this is super interesting because we still have a lot of teams that have just not database-based archive system, but file-based systems. And this is a very good path to actually get to a more scalable system. And on top, obviously, I talked a little bit about this, is the UI. And when we started building these systems in our customer projects, we found that's actually a lot of work to build this layer, because you have this readily available tool like Power BI, Superset, Grafana, but it's not something that you can actually integrate into your own assistant very well. Also, these tools are not built for engineering data. The support, for example, for larger amount of time series is quite poor. So what you typically have to do is you have to start quite with a low level, use charting libraries, and use the ones that at least support time series reasonable well. And what we started to do, and what we hope to do more in the future, is to actually, from our project experience, build a new abstraction layer for other teams as well, that allow you to build these assistants, the UI level for the assistant, much quicker than it's now possible. And it's, I'm convinced that if we want to do this successfully, we have to do it open source to get the adoption that is needed to actually build something that lasts. And this is something that we actually learned. We have a, I would say, like reasonably successful open source software for data curation. So it is like a different target group. It's more machine learning experts and data teams. But we learned a lot about how to build communities, what works well, what licenses work well, and how we build business models around it. So so that's the next step for us. And if you're interested in this topic, having UI toolkits for assistants, and especially for data assistants, if you are running, developing these assistants into your platform, really happy to hear from you, to get in touch, share a little bit more in depth what you've learned, what we've learned about the different technology stacks. And very specifically, we're just starting several actually projects that are publicly funded. So if you're from a company that loves doing publicly funded projects, again, really happy to hear from you. And also, if you'd like to actually try it out, we'll probably launch the first version towards the end of the year. Say hi, contact me. Really happy to hear your opinion on that, and really looking forward to hearing your experiences on the topic. Thank you.
So thanks very much. Thanks very much, Stefan, for this interesting insights. Are there any questions? Yes, Martin?
Yeah, Stefan, thanks for the talk. So I have one question. You showed this tech stack, right? You showed, maybe you can go to slide. Is this one agent what you have built, which is using this SQL staff transformation as tools? So are they tools, or is this more a kind of multi-agent system what you have built here?
It's a multi-agent system. So here you have a layer that actually chooses which agent to use, basically, and then you have like the different agents.
Okay, cool. Yeah. Thank you.
Yeah, and I think there are like very different methods of doing this, and I just picked the SQL agent as an example. So what you can do is you can actually have a SQL agent that can do all of SQL. So a very like powerful thing. Super complex natural language queries can be converted into SQL. And this works well for many tasks, but this can fail, obviously, right? But what you can also do is you can provide like just specific functions for stuff you use very often, and obviously the failure rate then is not as much, is not as high. And then you can also mix them. So I think this is an interesting choice to make, and I think it's true for some of the other agents as well. You can have like an agent that just has a very narrow field, but is very stable, or you can have agents that are very capable, but are not as stable, right? Yeah.
Good. More questions? Yeah.
Hi, yeah, thank you for the talk. So I also want to ask about the Metal Llama model that you used.
Yeah.
Was it the quality good in selecting the correct tool, or you had to fine tune it or do some?
Yeah, thanks again. It's more, again, in the more technical details, but we found that in contrast to document rag, for example, these local models work quite well for the stuff that's needed here. Also for the text to SQL, there are some fine-tuned 7 billion and 8 billion models that are actually pretty good already. So this is, I think, one of the advantages of this use here, that the local models that run fast and in automotive that also run locally, there's no data exchange, so work so well. Yeah.
Okay, and one more.
Yeah, so maybe even digging deeper into the technical weeds, but so text to SQL sounds great, right? And in general it works, but if you have like really complex SQL tables and schemas, how do you like? Where's the limit of complexity in your SQL that the agents can still properly handle?
Yeah, good question, and I think the most honest answer is I don't know. I mean, we run a lot of tests, and there definitely is a limit to what it can do. And again, what we do in the real system and the real proof of concept system with the customer, we actually also have like agents that are like narrower, that just give you events based on maximum and minimum value, for example, to actually like hit a very high stability mark for, I would say, like the standard questions, right? And I think there definitely is a ceiling to what you can do in terms of complexity with text to SQL, for sure. But in this scenario, just actually even getting, for example, you have like vehicles and you would like to ask when or how many times was a vehicle using more than 500 Newton meters of torque. So this is a typical question. Currently, this takes days to answer it, but from a data point, it's quite easy. You just have to know where's the torque. You have to have a simple aggregation over this threshold value. So, and even these types of simple queries already provide a lot of value. I think this would be the most the important part of the answer.